All right, this is the third part of our limiting reactant series. And in class, some people are still quite unsure how to get the problem started and carry it through to the entire process to come up with the uh, theoretical yield, percent yield, and excess reactant. So I'm going to work this problem a little bit differently, just slightly, to give you a better understanding of what we're doing to find the theoretical yield, and that involves identifying the limiting reactant, calculating percent yield number 2, and then calculating the excess reactant. So let's start out by writing down, as the book does, some relationships that we need. So we see we have uh, S8 and O2, and we have SO2. So it would be a good idea to go ahead and calculate the molar mass of our two reactants in our products. So we could go ahead and write out some known relationships. So let's go ahead and do that. So 1 mole of S8 is equal to 256.5 grams of S8. Okay, the next molar mass would be O2. 1 mole of O2 is equal to 32.0 grams of O2. And the next molar mass would be SO2, our product. 1 mole of SO2 is equal to 64.1 grams of SO2. Okay, now we want to start with the given reactants and their amount in grams and carry it through to determine the limiting reactant. So the first thing we want to do is start with the first thing we're given right here, and let's say we have 160 grams of S8, and we want to take grams of S8 to moles of S8. So 1 mole of S8 is equal to, from our molar mass, 256.5 grams of S8. Okay, now at this point we want to look at the balanced chemical equation to get our mole to mole ratio. We want to look at our balanced chemical equation to get our mole to mole ratio. Sometimes a student will look here and say, I got 1 mole of S8 here, and I want to cancel that with 1 mole of S8. But doing that, just writing 1 mole in the denominator without looking at the balanced chemical equation to get our mole ratio, that would be wrong. So we have to indeed look here and see that we have 1 mole of S8. So that's 1 mole of S8. And how many moles of SO2 does that produce? So we have 8 moles of SO2. okay? That came from our balanced chemical equation. So moles of S8 cancel, and now I'm in moles of SO2. The next thing is to do this calculation, this multiplication and division, and you will wind up with 5.0 moles of SO2. Okay, that's how much it gives you, 5.0 moles of SO2. So one important question here is, what is my limiting reactant? What is my limiting reactant? Take a minute and think about that. What is your limiting reactant? Okay, a minute has passed. We don't know what the limiting reactant is because we've only calculated the amount of SO2 produced by this reactant S8. We haven't carried the other reactant through the process. Therefore, we cannot tell, okay, what the limiting reactant is. So, you have to go here and get this number, the 155 grams of O2, and carry it through. So 155 grams of O2. And we want to go from grams to moles. And up here are used relationships that we already wrote out. Our molar masses say that 1 mole of O2 produces 32 grams of O2. Grams of O2 and grams of O2 cancel. So now I'm at this point again where we have to calculate, or we have to use rather, the mole to mole relationship from our balanced chemical equation. So from our balanced chemical equation, we say that 8 moles of oxygen produces 8 moles of SO2. So 8 moles of O2 gives us 8 moles of SO2. All right, that only came from our balanced chemical equation. So you can say we can get to the limiting reactant from a gram to a mole in a 3-step, going from grams to moles and then our mole to mole ratio. So actually 2 steps. So that would be grams to moles using molar mass, and then our mole to mole ratio using our balanced chemical equation. So that calculation would give us 4.84 moles of SO2. All right. Now, when we compare these two numbers, we see that 155 grams of O2 produce the least amount of moles of SO2. So the limiting reactant would be O2. So 155 grams of O2 is our limiting reactant. This is our limiting reactant. Okay, now we have one more step, which is number 3, says calculate the excess reactant. So to calculate the excess reactant, we have to go back and start with our limiting reactant. Now this is a very much importance because this step is left out of the book. We know that O2 is our limiting reactant, and by default S8 is our excess. However, we need to calculate the amount of excess. The amount of excess. So let's say, go back to our limiting reactant and 155 grams of O2. And we want to go from grams again to moles using our molar mass. Now, at this step, again, we would use the mole to mole ratio from our balanced chemical equation, but the mole to mole ratio would be the limiting reactant mole to mole ratio, which is 8 moles of O2 to the excess mole reactant. So the excess mole the excess reactant mole ratio would be here 1 mole. 1 mole S8. So I'll repeat that again. This step here, we use the limiting reactant mole ratio to the excess reactant mole ratio. So that's the different step here, where we use the product that we were trying to find in these 2 steps. We want to know what the mole ratio is to the excess reactant. Okay? So, and at this point, we would have to carry it out to grams. We could not stop at moles because we're given an amount of S8 in grams, and we want to find out how much excess. So again, here we would use 1 mole of S8 gives us our molar mass again, 256.5 grams of S8. So moles of S8 and moles of S8 cancel. Now that is equal to 155.3 grams of S8. All right, that means in particular that this 155 grams of O2 consumes 155.3 grams of S8. That's what that means. So when all the limiting reactant is used up, the reaction stops. The reaction stops, as I've previously stated, when all the limiting reactant is used up. So let's take a look here and say that the excess reactant excess reactant is equal to the 160 grams of sulfur of S8 minus 155.3 grams of S8. Okay, so when we subtract those two, the actual amount of S8 consumed by the amount of S8 we start with, that gives us the excess reactant. So when we subtract those two, we get 4.7 grams of S8. And this is our excess. Okay, so that's how we would calculate the excess. So this is another example you can look at and practice.